everybody. I am Chandra Jagan Mohan, and today we will discuss about the topic. Today we will discuss about the topic um, gas turbines. See, we know that the turbines. So while discussing our subject, so we are discussing about the subject. We are discussing about the subject, the power generation. See why the power is needed, and how many versatile types of power we can generate. Yes, everybody knows we can generate power from the wind, from the sun, from the ocean, from the water, from the earth, from the coal. So there are so many methods of power generation. There are so many methods we are having. And this electrical energy, we were able to convert this electrical energy into so many energies we required. So even though there are so many methods, still there are so many methods are upcoming. There are a number of methods, but the thing is that all the methods did not become famous. Only some methods became famous. So because of so many reasons, so availability, all these things, economics, technology, efficiency, all these things. So yes, so among them we were discussing. So steam energy, hydropower, wind power. So up to now, the methods of producing the power as on today, except the solar energy, that is especially the photovoltaic energy. The other methods require a turbine. They require a turbine. So because in some way or other, we are using the mechanical power. We are using that energy to be converted into mechanical energy. So that force, and the turbine is rotating, and that is connected to the shaft, is connected to the generator, and the generator is going to rotor of generator is going to rotate, and the EMF is going to induce it. That's all. That's the common thing everybody knows. So we are using the turbine in almost everything except the photovoltaic. There, the energy is stored into the batteries without the requirement of any turbine. So the photovoltaic energy is converted into the electrical energy there. So in between, so there the photovoltaic energy is there, and it is converted and it is directly stored into batteries. So as a medium, there is no conversion process of energies. Some energy, the photovoltaic energy is not converted into mechanical energy. No need. It is directly coming into the electrical energy. It is stored. So because that photons are able to move the electrons directly. So the movement of electrons and the current is stored in the batteries. But if you come to the another methods, all the famous methods, conventional, non-conventional, except that photovoltaic way of generating the photovoltaic way of generating the power. We need turbines. If you go to the geothermal energy, yes, that steam energy is converted, is used to rotate the turbine. So there we are requiring a turbine. Hydro, the water energy is used to rotate the turbine. And nuclear, thermal, and also the newly upcoming, that is wind energy. We are using that potential of the wind with the help of the fans to rotate the turbine, and so that is converted into electrical energy. Even in the solar thermal energy also we are going to rotate. So except some chemical energies, so nowadays we are doing research, the electricity from the plants. Yes, there also we are not using any kind of turbine. So that due to the chemical reactions, the plants are releasing the electrons into the soil, so that we are capturing. So wherever the electron moves, there is a hope of power. So that's why a turbine is very, very important thing. So which is going to convert that force of any kind of energy, into the mechanical energy. Again, it is converted into the electrical energy. So even though we are discussing about we are going to discuss mainly about the gas turbine, we are going to compare with other turbines. See, majorly we are going to, first thing we have used is that the hydro energy. There we are using the turbines, and we have called them as the hydraulic turbines. Because they are designed such that the potential of water is converted into the mechanical energy. So there are different types, that is impulse, reaction, high head, low head, medium head, high speed, low speed, medium speed. So all this tangential for vertical jet, tangential jet, flow, axial flow, radial flow. So based on those things we have, but basically only 3 types. Simply we can say that Francis, Pelton, Francis and Kaplan turbines. So they are designed to meet that purpose of hydraulics. for producing the hydropower. If you come to the steam turbine. So here what happens there, not only the design, here we have to see in such a way that, so if you go to the hydraulic turbine, depending on the force of the water, the pressure of the water, the movement, so different shapes of the turbines are there, and there only the problem is with the water which may lead the turbine to for corrosion, for rusting. So the metals, the alloys suitable for that we were using actually. So if you come to the steam turbine, what is happening is that, so there the temperature is not, so the water temperature, so within the limits, so temperature, while designing the turbine, there is no constraints about the temperature. But if you come to the steam turbine, we have to see, so not only that turbine should be made such with an alloy such that not only it stops, it will be protected from the corrosion or rusting, and we have also see such a way that it can withstand that temperature, high temperature. Steam, super steams. So nowadays we are using the super steams. So the temperature is one of the big criteria. The temperature is one of the big criteria where we have to think while designing the steam turbines, along with the corrosion, all these things, mechanical strengths, the force. With the rotation also, you will be getting some heat. Along with that, we have to take care of the high temperature of the steams, super steams. So that designing is somewhat different. So we have to allow that steam to expand into the blades in the turbine. The jets, they will move out from the jets. Probably more jets will be having and more blades. So these jets will release the super steam or steam with having high pressure. So they will expand, and that expansion force is captured by the blades and they will rotate. That's what is actually going to happen. And not exactly the similar thing for the gas turbine. So for the gas turbine, we are using the explosion power of the gases, flue gases. So whenever the burning happens, so what happens when a bomb explodes? So much of force will be released because of the chemical reaction in the air. So much gases are released very fastly with so much of force. So that exploding force we are using to rotate the gas turbine. So here we have to take care while designing the gas turbines, so such that it will withstand so much of high temperatures. 2300 degrees Fahrenheit. Normally we are designing such a way that the turbine can withstand the temperature of 2300 degrees Fahrenheit. So it's because of not only the burning happening in the turbine and also the speed. It rotates with very high speed. If you compare with the hydraulic turbines, so they are somewhat slow when compared to the steam turbines. If you compare the steam turbine with the gas turbine, the speed is somewhat low. So the gas turbines are going to rotate with the speed, the higher speed than the hydro turbines and steam turbines. So because of the speed also, so much of temperature. So, but with more high temperatures releasing in the turbine and more speed, we are going to get good efficiency. So that's why in 2000, a good breakthrough happened. A breakthrough happened in the technology of the gas turbines. So they were able to design a turbine which can stand the temperature of 2600 degrees Fahrenheit with 60% thermal efficiency. With 60% thermal efficiency. So that is a big breakthrough in the field of the gas turbines. So this is the overall introduction. So now we will move. So the gas turbine is very simple. It's very simple. So it is having mainly three parts, that is compressor, combustion chamber and the turbine. Okay. So it's simple. The compressor is going to rotate and suck the air and send that air with high pressure into the combustion chamber, where again we are going to inject the fuel and burn that fuel with the high pressure air. Okay, compressed air. Burn that fuel with the compressed air. And whenever the fire starts, the burning happens like explosion, and that force is captured by because of that burning and of that explosion. So much of gases with high pressure will be moving out from this combustion chamber to the turbine. So this force of that gases released because of that combustion will rotate the turbine, and so after exhaust the gases will move. Okay. So here you can observe here. So here the air is sucked. The air is sucked inside into the compressor because of the rotation. Yes, this is run with the motor, with the help of the motor. So for this running, we are using the power which is generated. So here is the key point why the efficiency of the gas turbine is is less, because almost we are using so much of power produced to rotate the compressor. So that is major thing. Okay. So after compression, it will move into the chamber with as it is compressed air. So there we are going to supply the fuel and we are going to burn, and high pressure gases are released because of that burning, and they will move. Also, while moving, they will be having so much of kinetic energy. They will rotate the turbine and they will go away. So after exhaust, they will go. They are going to move away. So the main points, the main parts are air compressor and combustion chamber and the turbine. So you can observe here, there is a shaft here. So shaft here and compressor, combustion chamber, turbine. So the duty of the air compressor is to suck the air and send the compressed air into the chamber, into the combustion chamber. So for that, we are going to use the motor. For rotating that compressor, we are going to use the motor. So what happens in the combustion chamber? Already, so the compressed air is going to mix with the fuel and we are going to burn it. So much of gases are going to release with high velocity, are going to release because of that burning. So next turbine, it is a multi-stage turbine we are using. So where we can use properly the velocity of that gases. It will be having blades, rotor and shaft, which is going to couple with the generator. Normally the turbine will be coupled with the generator. So what are the applications? So applications are, we can use them to drive pumps. We can use them. So majority we are using the gas turbines. In fact, we have to say the gas turbines we are using for the power generation is less when compared to the gas turbines we are using for the aircrafts, for moving the aeroplanes and ships, and also we are going to use in the high speed cars. So this is the gas turbine is it's a very simple thing. It's very simple thing, and also it is very robust. It is also cheap. The construction, the installation cost is very less. So it is having its own advantages, so many advantages. Okay, and if you see the advantages, so because it is simple, the operation is also simple. So the construction is also simple. So it is cheap. The manufacturing is cheap. Since the operation is simple, the maintenance cost is less. And also here there is no need for storage of fuel. There is no need for storage of fuel. And there is no need for boiler, condenser, other accessories as for the steam turbines. Those things are not needed here. So the installation cost is very high. So we can use cheap fuels like kerosene, powdered coal, benzene, paraffin, So we can use the cheaper fuels than the petrol and diesel here. So whenever, if I go to the desert, if I go to the Arab countries where the water is cheap than the oil, so there I cannot construct a hydro plant. Even the thermal plant, because for thermal plant also so much of water is needed for converting it into steam, for condensing, for cooling. So in such things I can go for this gas turbine where there is a scarcity of water. Scarcity of water. And also the pollution is less. Here the pollution is very, very less. If you compare with the steam turbines, so much of ash pollution is coming, ash is coming. So that problem is not there. Okay, but similarly we are having, for anything we'll be having disadvantages also. So because the disadvantage is that, as I have told you earlier, that 66% of the power which is generated is going to use for the motor to drive the compressor. So that is the major disadvantage. So that is, the efficiency is only up to 30%. And also the thing is that it is going to rotate with very high speed, 40,000 to 1 lakh RPM, rotation per minute, 40,000 to 1 lakhs. So you can imagine what is the speed. If you compare with the hydro plant, hydraulic turbines, steam turbines, there is no matching at all. And the temperature also, very high temperatures, 1100 to 12,600 degrees centigrade. So normal metals will melt. Normal metals cannot melt. So the designing is, so it has to withstand that speed, the mechanical stress, and the heat. So you require special alloys, super alloys. Okay. So that is, and that is very, so you are going to require a high technology for that. And also, since it is running with very high speed, up to 1 lakh RPM, from 40,000 to 1 lakh RPM. So you can naturally, the sound is unbearable. The noise is unbearable. The noise is very much high. So that's about the gas turbine, but we will compare. If you see that there is no matching, if you compare with the efficiency, if you compare the speed, if you compare the temperatures, that much of speed it is going to rotate, that much of high temperature it is going to operate. but the efficiency is less. But the advantage is that the installation cost, the area is less required, no need for the boilers, all these things, condensers, cooling towers, all these things. Okay, we will see a small comparison here. So we know that the gas turbines are mainly used in the aeroplanes. That is, technically we can say it as aviation. So both cases we are going to use the gas turbines. So in the aviation, the main aim is that we have to produce the thrust, and in the land, so that land gas turbines means that the turbines which we are using to generate the power. So here the main thing is it has to produce more mechanical energy. Here the requirement is mechanical energy. There the requirement is the thrust. There the requirement is thrust force. Here the requirement is the mechanical force. And the end component is for the aviation is that nozzle. Here naturally the generator. So here we are going to produce the power. We need to produce the power. So generator is the end component here. If you any hydropower, thermal power, nuclear power, wind power, the end component is ultimately the generator. So weight and size. So here we don't have any constraint if you want to generate the power. Okay. No constraint with the size, no constraint with the weight. But if you go to aviation, yes, it is a constraint. So if it is having more weight, it's a problem for the aeroplane. Size also a problem. And the fuel in aeroplanes, that in gas turbines of the aeroplanes, we are going to use single fuel. Here we can go for different fuels, gas, benzene, kerosene, powdered coal, different fuels. We are having option here. And as I told, there is breakthrough has happened in the year 2000. So they were able to make a gas turbine which can withstand the high temperature from 2300 degrees Fahrenheit to 2600 degrees Fahrenheit with 60% of thermal efficiency. So that is a good breakthrough which has happened. And we were being always comparing. Yes, we have to compare. So since there also we are using thermal energy, here also we are using thermal energy. So we need to compare this gas turbine with the steam turbine. So the gas turbine means it's not going to depend on the water availability. But if you go to the steam turbine, yes, it requires so much of water, because the water is only we are going to use it as the force. We are going to convert into steam. So the gas turbine, the space installation is less, and in the steam turbine, the space for installation is high. The efficiency, yes, the efficiency of the gas turbine is less. The cost is also less. The installation cost is also less. Maintenance cost is also less. But the efficiency is also less. But for the steam turbine, the efficiency is high. It is going to work on the flue gases. So the gases which are released because of the burning gas turbine. But the steam turbine is going to work on the fluid, that is steam. So the installation cost and running costs are less for the gas. They are high for the steam turbines. And the controlling of the turbine. So if you go to the actual supply, distribution, generation, after generation, if you go to the distributing to the load will be continuously fluctuating. So in correspondence with that, we have to also continuously change the generation. So if the load decreases, we have to decrease the generation. If the load increases, we have to increase the generation. So it's actually the purpose of this SCADA. So in that, we have to change. So in that scenario, we can easily control that. We can easily control the production of we can easily change the production of the power in the gas turbines when compared to the steam turbines. So fastly we can react here. We can react very fastly here. And also a gas turbine is very quick start. So suppose if you want to compare this type of power generation, probably we can compare with the pumped storage dam. Probably, maybe. So very quick. If the demand, we have to generate power very fastly, it will within very short time, it is going to pick up that generation because it is burning. It's releasing so much of gases. That type of very quick starting is not possible in the steam plants. In hydropower plants also, that quick starting and quick stopping. Yes, even quick stopping. That means very quick rising and very quick falling. Yes, rapid rising and rapid falling of power generation. If you want, it is possible in the gas turbines, but it is not possible that much with that much of speed in the steam turbines. It is not possible in the steam turbines. So that's why we can say the gas turbine we can use in the areas where they are having the fuel, high fuel, where the fuel is cheap and the land is less and water sources are less. In such cases, you can go for gas turbine. And if you come to the steam turbine, yes, it is a device which will produce the mechanical force. It was invented by Sir Charles Parsons in 1884. The steam turbine was invented by Charles Parsons in 1884. And the principle is that it is going to expand the steam, is going to expand on the blades with high pressure and temperature. It is going to come out of the nozzles, forming a high velocity and going to expand on the blades, and that force is going to rotate the rotor. Here you can observe the nozzles. From there, the steam is going to come out with high pressure and velocity, and it will fall on the blades, and the blades will move. They are going to expand. So here also there are two types, that is impulse and reaction. You can observe. So the steam is directly falling on the blades here, so creating the rotational force in the impulse type. That's why it is called as impulse. Here it is reaction. So the steam is going to move inside S type of nozzle, creating the velocity. So it is the reaction. So that's why it is the reaction. If you come to the as I have already told you, the making of a gas turbine is very, very difficult, because we have to deal with very high temperatures and high speeds. So there we are going to use the special steels, titanium alloys, super alloys. So this requires a very advanced technology. So the special steel is made by adding various elements to iron. So the steel, the thing which is an alloy of the iron. It is used in the gas turbines, automobiles, all these things. So and also we are going to use the titanium alloys. So it is a mixture of titanium and other chemical elements. So it is going to become a very good alloy. So its symbol is Ti, and atomic number is 22. Atomic mass is 47.86 U. And the melting point, you can observe, it is 1668 degrees centigrade. You see. So it is only going to melt at the high temperature of 1668 degrees centigrade. That's why we are going to use this in the manufacturing of the gas turbine. And similarly, the super alloys. So the super alloy means here we are going to use for making a very good mechanical strength and thermal creep deformation, good surface stability, and resistance to corrosion and oxidation. So this is a super alloy. Okay. So we are going to use this type of super alloy, which is having with high mechanical strength, which can have high thermal, high melting point, and very good surface stability, and which is having good resistance of corrosion and oxidation. And there is a small difference between the corrosion and oxidation. That is, so the corrosion is going to happen to metals, especially for metals. Oxidation is going to happen anywhere. So presently we are using a very good alloy, which is called a CRMOV alloy, low alloy steel. So with 1% chromium, 1% molybdenum, and 25% vanadium, up to 0.3% carbon, the balance iron, and possibly less addition of silicon. So these are type of alloys we are going to use. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.